Hello, everyone. Can you hear me? Okay, that's great. Okay, so let's start. First of all, an acknowledgement of the country. I would like to acknowledge the traditional owners of Australia and recognize their continuing connection to land, water, and culture. I am currently on the land of the Burra people and pay my respect to their elder, past, present, and emerging. I further acknowledge the traditional owners of the country on which you are on and pay respect to their elder, past, present, and future. Today we'll have a look on relational algebra and SQL, but before going there, we have some unfinished business from last week. If I remember correctly, this is where we stopped last week. So only few topics we have missed last week. So first I will go through these, then we will start learning about relational algebra and SQL today, okay? So last week we were learning about how to convert our conceptual design into logical design. So in week 2, we learned about how to design that ER diagram. And week 3, we are learning about logical design. So we stopped here that when we have a weak entity set, how should we convert that one into a logical table, right? Hopefully you got some idea when we have a weak entity set like this. So here department table is a weak entity set, and this is the weak relationship that we have. So in that case, how do we create the primary key? So we simply take the primary key of this parent table and also the discriminator from this weak entity set. Right? So we combine that two, like in here, employee ID and given and family, because name was the composite attribute. So we have to take given and family. That's how using these three, we create only one primary key for this dependent table. Right? That's it. Nothing extra that we need to learn in here. So this one is simply showing that the foreign key is coming from this employee table, right? Should be understandable by now. Next was is a hierarchy. So when we learned about ER diagram, let me simply go there. So we see this sort of relation between tables, right? Which was is a. That simply means that employee is a person or customer is a person. Right? So that simply means employee table is connected with person table with some relation. So if you remember when we designed this one, so we said that this employee table have all of these attributes as well, like PID, street, city. Customer also have PID, street, and city. Okay, because of these two extra attributes for these two tables, we are creating these two separately, right? So how should we create? First, let's create person table. So if we simply create person table, that one should contain PID, street, and city. When we are creating employee table, do I need to take all of these things? Definitely not, because we have this idea now that since this is the primary key, knowing only this one, I can get all the information, right? So how should employee table look like? Employee table will have only PID, the primary key of this person class, because using the person primary key, we can get all the informations and the extra attributes that we have. Same thing for customer, PID will come from this person table, right? And also have this extra attribute credit rating. That's how we'll simply connect all of these tables. Last thing was aggregation. So aggregation, if you remember when we are trying to connect a big table where we have some other ER diagram inside that table with another table, right? Using a relationship. So we here know how to connect all of these things. Only thing we need to know how should enrolled file looks like, right? So if we first create the tables for this internal structure first, so student, unit of study, that should make sense. Student have SID and name, unit of study have unit code and title. How should enroll look like? Enroll should only get the primary key from these two tables, right? So SID will come and unit of study code will come to enroll table. That one will create primary key, and those are the foreign keys as well. That's great. Employee table, that is a simple table, no issues there. So the employee table will have employee ID and designation, these two attributes that we have, and employee ID is the primary key there. right? It's already mentioned. So this is how we'll create. Only thing is, how should we create this enrolled by? How should we connect? So in here, enrolled by is actually connected to this enroll table. Why? Because enroll table have all the information of this big table, right? So enroll table is connecting student table, enroll table is connecting unit study table. So if I only get access to this table, I can get all the informations. So that simply means we'll simply connect enrolled by with this enroll table. So how do we connect two tables? So we have to take the primary keys, right? So we have to take primary key into that table, and that's how we connect. So what should be the attribute of enroll by table? Definitely one coming from employee table, right? And another should come from enroll table. Now, what is the primary key of enroll table? SID and unit code. Both of them combinedly created the primary key, right? So how many attributes now we will have in enroll by? Definitely 3. SID and unit of study code coming from this enroll table, right? And employee ID is coming from here. So this is how we will convert this aggregation into actual tables. Hopefully making sense. Now we have that idea how to create all of these, right? So this one should make sense as well. And I think that was it, which was left. Any question on this part? We learned about ISA, aggregation, and weak entity set. Before I move to this week's content, any question from anyone? Looks like fun. That's great. If you have any question, feel free to ask at the end. Okay, I'll be happy to come back here and explain again. Okay, so from today, we'll actually learn about SQL, which was the most important part of this unit, right? So, but before going there, we simply need to know about relational algebra. Once you understand relational algebra, SQL should be easy. So in relational algebra, we will today see 6 basic operators. That's what we are going to learn, and how those 6 operators we can convert into SQL. Okay, so in SQL, we will also learn about basic queries, some join when we have more than one table, and set operations. Okay, we'll also cover SQL next week as well. Okay, so if you have any question today, feel free to ask next week as well if something does not make sense. Okay, these 3 tables will be used throughout this session today. Okay, so I have a closed loop. What are the attributes? What are the value? Okay, this one will come up again and again. So in here, I have a student table. I have unit of study table, and they are connected by enroll table. If we convert them into tables, actual tables, you know how should it look like. So student table will have SID, name, gender, and country. Unit of study code will have US code, title, and points. And enroll table will have primary key from student table, primary key from unit of study table, and has its own attribute, which is semester. So all of those things are there, and some example values are there as well. Okay. So here I have 6 students, and here I have 6 courses as well, 6 units as well. And enroll table is showing which student is enrolled in which course, which unit of study, right, in which semester. So those sort of informations are there. Based on that, we will write some SQL queries and some relational algebra. Okay, first, relational algebra. So when we are writing a simple query, let's say this is the query that we are going to write in relational algebra. Find the title of all units worth 6 credit points. Looking into these 3 tables, how many such units should I find? Can you find from the 3 tables? Can you answer? Find the title of all the units worth 6 credit points. How many units have 6 credit points? Someone said 3, 3, 3. Excellent. Okay. So to answer that thing, you are saying 3. How many tables do you have to look? Do you have to look into all the tables, or 1 table, or 2 tables is enough? Only 1 table. Which table is that one? Yep, someone said point. Point is not the table, point is the attribute, right? Yes. So we only need unit of study table. So that is the first thing we have to do. We first have to figure out where can I get that information. That is the first thing that we have to do. Okay. So this should be the result. These three should come, but how that thing would come, that is what we need to understand. So first we need to figure out that student table has no significance here. Enroll table should not be here as well. Only this unit of study table is of interest to us, okay, to answer this question. Okay, so now we have only this table, other twos are gone. I want to answer this one, right? So how should I find who will have 6 credit points? So let's put that condition. Looking into the points, right? So we definitely can figure out all the units that have 6 credit points. If I do that, this is known as selection. This operator we'll talk about, don't worry. Just this one is the condition that only says where points equal to 6. So points means the attribute name. Here we'll go. Here we'll see, is it 6? Yes, so that one will come. Is it 6? Yes, yes, no, no, no. So only these first 3 rows will come, right? So here I have unit of study code, title, and points. Everything will be there, and these 3 rows will come in here. Now the question is asking, give me the title. But this one is showing everything, unit of study code, title, points, everything. Question is not asking that. Question is asking only give me the title only. So from this one, I simply need to print this title. How would I do that? We will use another symbol. Okay, this is known as projection. So we'll simply write project on title. Okay, so if I do that, then we can see that only title will be in the output. Okay. So if I combine these two, this is what it should look like. So now we understood that it works from inside out. Okay, so first we are writing the table, unit of study. On that, we are putting a condition where point equal to 6. Okay, if from there we get this output, from there we are putting a projection. Okay, so we are saying just show me the title, not everything. So this operator is known as projection. Okay, so projection will only project whatever you have written in there. Okay, and this is the condition part in Sigma. In Pi, we'll write the projection. I'll talk about that one more. Okay, what about this one? Find the student ID of all the students who are enrolled in COMP9138. Okay, just think about what table do you need and how you can write that one. Find the student ID of all students who are enrolled in COMP9138. Which table do you need in this case? Someone is asking, what does project means? I will explain in a minute. Okay. Yep. Few of you already figured that one out, that we only need enroll table in this case, right? So this question is asking who are enrolled in COMP9138. So I have a unit of study code here, and I need to print out the student ID, right? So which is also in this table. So only enroll table is enough to answer this query. Like I said, that is the first thing that we have to figure out, in which table we will find the answer, right? So this is how we write. So from enroll table, select all the rows where unit of study code equal to COMP9138, and then only show me the student ID. Okay, so project simply means simply show this one student ID, and that's what this one is asking. Hopefully making sense. If we do that, this is the output that we are going to get. So now we have this idea that in a relational algebra, there will be different operators and we can compose them, right? One inside another one. And here we describe step-by-step procedure, right? So in this table, first apply this condition. So it will get some rows. On that one, project on some columns. So show me only those columns, right? So we can change them, and that is a step-by-step procedure. Later we'll see today how we will convert this one into an actual SQL query, which we will be able to run and see the output. Okay. We'll not be able to write a relational algebra directly, but we can write SQL queries. Later I'll show you in the second part of this lecture, and there we'll see the output, how it comes. Internally, this is what happens. So from the front end, we write the SQL query, but when we submit that one or we click on run, so the DBMS system converts that SQL query into relational algebra expression. Okay, so this is the front end. In the background, the system will always convert the SQL query into a relational algebra expression, and then we'll figure out a plan, then finally execute that one. Okay, we'll talk about this part in week 10 and 11, how to execute or how to create a plan and how to execute. Okay, but this is at the part that we are seeing today, SQL query and relational algebra. Okay, so relational algebra will not be able to write and to see the output, but SQL query is what we can write. But we still need to understand how we can convert from SQL query to relational algebra or the other way around. This figure, like I said, it will come up every week almost. Okay, so today we are in this part. We will be sending a SQL command, and in this part, the parser, optimizer, they will convert that into relational algebra, and this executor will actually execute. Okay, so these parts, each of these parts we will learn on week 8, I think. Okay, for what does parser does, what does optimizer does, but today we'll simply learn how to convert from SQL query to relational algebra or the other way around. Okay, okay, so what are the basic operators? So far we have seen two. This one, like I said, the name is selection, and this pi, this one is sigma, this pi, this one is known as projection. Okay, so there are some operators that removes part of a relation, and you can see that these two removes the part of a relation, right? So selection selects a subset of rows. So selection will give you the rows, the whole row. Projection, someone was asking, so some projection simply means it deletes the unwanted column. So it works on the column. Okay, so if you write project on this column, so you will only see that column, everything else will be deleted. Okay, so selection works on rows, projection works on columns. Very simple thing. When we have more than one table, okay, we need to join those tables. Okay. So to join those tables, we will have two operators in here. First one is known as cross product, and second one is known as join. So cross product simply means we will combine all the tuples from these two relations. Join simply means there will be matching, there will be some conditions checking, okay, whether this condition is true or false, those sort of things we'll learn. So we'll learn for each of these today. Other operator that we are going to learn are known as set operator. So set operator, you're already familiar with union, intersection, difference, right? So union means take everything from these two. Intersection means what is the common values there. Difference means it exists in relation one but does not exist in the other one. So we'll learn about all of these. So these 1, 2, 3, 4, 5, 6, 7 operator we are going to learn. There is also another one known as rename. So if we need to rename an attribute or a table to write our query, okay, so we can do that using this symbol. So remember the symbol sigma, pi, simple cross is the join symbol, then union, intersection, difference are same, and this is the rename. Okay. Row is the rename. So all of these we are going to learn one by one. So let's start with projection. So what does projection means? It simply means it will extract the columns for attributes that are in the projection list. So in the projection list, here is the list. Okay. So it will extract those columns. It will only show you the column for name and country. This is what we are saying. So from student table, if I write name and country, this is what I'm going to get. In student table, I had other attributes, gender, student ID, those sort of things, but we are only projecting into this one. It removes removes the attributes which are not in the projection list, and also it eliminates duplicate rows. So when we are in relational algebra, it automatically eliminates the duplicate rows. So we don't have to worry about duplicates. So if I, let's say, only take country, project on country from student table, right? So this is the part of student table here. We can see that Australia and Australia are twice in here. Since it eliminates the duplicate rows, so we will see Australia only once. Okay. So relational algebra automatically eliminates duplicate rows. So that's why we are only seeing Australia once, although we have Australia twice in the actual table. Okay. So that is projection. It works on columns. That is the main thing. Selection, now we got that idea. The selection works on rows. It only selects the rows that satisfy that condition. So here we will write a condition, either equal to condition, greater than, less than, not equal to, any sort of thing. Any sort of condition we want to put, we can put in here, right? So this one is the condition part. So this condition is saying select the rows where country is equal to Australia. So from the student table, we are going to get only these two rows because here the country is Australia. So in here, how many attributes we are going to get? How many attributes we have in this table on which we are working on? Okay. So all the attributes from a student table, SID, name, gender, country, so everything is coming up. But the rows which are unwanted, those one will not be here. Which only satisfies this condition, we will only see those rows. So that's it about projection and selection. These two are, you will use these two always when you are writing a relational algebra. The rest of the things, depending on the case, you will use or not use. But selection and projection, you will use all the time. Okay. So like we have seen, we can combine all of these operator that we have. So on a student table, first put a condition, then project on the name. Okay, and that's how we can get student names from there. So just to make sure that you understand correctly, find the name of the students who live in Australia. Again, find the name of the students who live in Australia. To answer that query, I wrote this one. Is it correct or not? Find the name of the students who live in Australia. This query is correct or not? Everyone is saying no. That's great. Any reasoning can you write? Why this is not? Because I have all the conditions. Country called Australia, I'm projecting on name. Someone is saying it will get error. Select should be first. Projection should be outside, name and country. Yeah, so remember the order, right? How the relational algebra works. So first he will perform this internal thing. So this part will happen first, right? This one, and the result of one, on that you will work in here. So this is the second part. So first he will get all the name from the student table, right? So this is what we are going to get. So the output of part one, this inside part, is this name. Now you are writing, give me where country is equal to Australia, but in this result, we don't have any country attribute. So he will definitely complain. Right? Hopefully making sense. This is just to remind you that it first works inside, then the result goes to this outside part that we have. So how should we write it? We definitely first put this condition inside and this projection outside. That way we first select all the countries, that country equal to Australia. Okay, that means this row and this row, right? And then if we project name, then we are going to get Jan and Grant. Hopefully making sense. Yep, so this is wrong. Okay, when we are writing conditions, definitely we'll have multiple conditions. We have to write multiple conditions, right? So we can combine those conditions using AND or. Okay, so this is the symbol for AND, and this is the symbol for OR we are going to use. And we have only seen equal to operator, country equal to Australia, but we can have greater than, less than, or any other operator that we can think of. Okay. So let's say for student table, I'm asking for the answer of this question, find out the male Australian students. Now we can see there are two conditions there, right? First condition is they have to be male, and second condition is the country should be Australia. So there are two conditions there, and they should be connected with the AND. So this is what we are going to write. Have a look, hopefully making sense. From a student table, this is the condition. where gender equal to M and country equal to Australia. This one is not saying specifically that give me the name only or SID only. So that's why we don't have any projection. So if we simply write this one, right? So we are going to get Jan and Grant, both of them actually. Okay. So these two rows will be in the output. Hopefully making sense that we can have multiple conditions connected with AND or if needed. Okay, so that's about projection and selection. Next thing is when we have more than one table. So far, we only talked about when we have the result in only one table. When we have the result in multiple tables, right? So we first need to combine those tables. How we can combine those tables? The first operator we are going to learn is cross product. You remember cross product from mathematics, right? So when we have these two sets, let's say R, here I have these values, S, these are the values. So if I do a Cartesian product, if you remember that term from mathematics, if not, that's fine. Cross product is also fine. So if I do a cross product, how many rows I'm going to see in the output? In here I have 2. In here I have 4. Okay, so in the output, how many rows we are going to see? Someone said 5, everyone else is saying 8. Yep, it will be 8, right? So for each row, so alpha 1 will have all of these 4, and then beta 2 will have all of these 4, right? So 2 into 4, which will be 8. Hopefully making sense, right? How many columns we will have? We will have 5 because here A, B, C, D, E, everything is different. So A, B, C, D, E, every attributes will be there, right? Hopefully making sense. So we will have 8 rows and all the attributes should be listed here. If we have common attributes, we will go there, but for the time being, we don't have any common attributes. All the attribute names are different. So we will get everything back. Hopefully making sense. Like this one is saying, if a conflict occurs with 2 fields of the same name, let's say this one is A as well, and this one is A. At that time, we have to rename one of the attributes. Okay, I'll show you examples. No worries. Just remember this thing. If R or S, if either of these is empty, has no value, okay, 5 is empty, then the resultant will become empty as well. Don't think that it will have 4 values. Let's say here I have 4, here I have none. So if I combine, it will still have 4 with null values. No, that will not happen. Okay. So if either of them is empty, then the result will become empty as well. Okay. Remember that thing. So when we are doing cross product, make sure you have some data so that you can run your query. Okay. This is also known as Cartesian product. Any name you want to use, that's fine. Okay, so now we have some idea about cross product, how we can join these two. Okay, when you want to put a condition there, so this is what we are familiar with now. So this is simply a cross product of R and S. We are familiar with this symbol now, R cross S. So in there now we are also familiar with this, and this is the actual condition that I am writing. Okay, so country equal to Australia. So this is what that thing represents, whatever condition you are going to write in here. So this whole thing we can write in a simple way using this way. Okay, so this operator is known as join, not cross. Okay, and then there is a condition. Okay, so this one will be known as conditional join. So cross is known as cross product or Cartesian product when we have a cross, but these are blocked. This one is known as join. Okay, so there are some differences. We'll talk about that. But in here, it simply means that on top of this cross, we'll have some conditions as well. Okay, so let's have a look. Let's say I have a student table and this lecturer table, student table and lecturer table, and I want to put some conditions for their joining. So let's say this is the condition. This is just an arbitrary condition, just to show you that yes, we can put some conditions. Let's say I'm putting a condition that the student's first name must be equal to lecturer's last name, or students SID should be less than lecturers employee ID. Some arbitrary conditions, but everything should make sense. This is the OR symbol that we have seen, right? Is this or and? Am I saying it wrong? Can you correct me? Is this symbol and or? And, yep. I was doing a mistake. Yes, so this and, okay? Make sure you don't make mistake like me. So this one is an and condition. So we have two conditions in here. Okay, so if I want to put some conditions on top of that cross, so that one we can do. So now it should make sense. So first we will do cross product, and then based on this condition, we'll show the output, right? So first we'll do cross of these two. So all the attributes and all the rows will be there. Then based on this condition, we will get few of them back as an output, right? So here you can see the condition is first name is equal to last name. So student's first name equal to lecturer's last name. In all the cases that is true, and SID should be less than employee ID. Okay, so yep, this is what conditional join means. This is also known as theta join because this is theta, right? So that's why in some books you will find that one as theta join. In some books it is written as conditional join. So both are fine. When we have in this condition everything as an equality, okay, at that time that join will be known as equi-join. So in these conditions that we have in here, two conditions, this number one, this number two, right? Is it equi-join? No, because here I have equal, but in here I have less than. So if let's say this one is equal as well, not less than. So now we can see that all the conditions are only working on equality. At that time, that join will be known as equi-join. Okay, so equi-join is simply a conditional join where all the conditions have equality, not greater than less than. Okay, so that is the simple difference. So next thing, this join now, when we write that one, we'll write as natural join. That is the keyword. Later you will see that when I write, I'll write natural join as the keyword. That's what I've written here as natural join as well. So this is the symbol for joining. So this one means equi-join on all common fields followed by a projection. Should make some sense. Now we understand what does equi-join means on all common fields. So first think about primary key foreign key relation that we learned, right? So in enroll table, if I have a student ID, that one is coming from a student table, right? So that SID in student table and this enroll table, when I join these two, those are known as common fields, right? Because both of these table have that attribute SID. So we will try to check whether they are equal or not first, and then we will do some projection on top of them. Okay, so on all the common fields, there will be condition checking, which is equal, whether they are equal, and then we will do some projection. Let's have a look in this example. So if I do a join in here, based on your understanding, how many rows will I get in the resultant out table? So first have a look which are the common fields in these two tables. Definitely unit of static code and unit of static code, right? So it will try to match unit of static code with the unit of static code. If these two matches, right, then that one will be in the output. If these two does not match, then it will not be in the output, right? Some people are saying 4, 4, 4, 4, 4. Unfortunately, that is wrong. Can we have a look again? How many rows will I get in the output? Yep, now people are saying 6 rows. 6 row, 4 column. Okay. Yep. So how this one will work? This one will try to compare like the common fields. That's what it's saying. So unit of static code, they are common. So we'll compare 5138 with 5138. Is that equal? Yes. So this row will come in the output. Right. For again 5138, we'll compare this. Should this come in the output? No. We'll check all of these. Then no. 5702 start. 5702. Do we have 5702 in here? Yes. This one will come as the output. 5138. 5138 matches with this one. Do I have any other 5138? No. So this one will come again. So that is 3. 5318. Yes, I have 5318. 6007. 6007. So this one will come. 6007 will come. And ISYS 3207. That one I have as well. So this one will come. Right. So 1, 2, 3, 4, 5, 6. These are the rows that will come in here. Since we have common attributes, right? They are same. We'll just write them once. So that's one is same. Specifically the first copy of the fields for which equality is specified. So it will only keep the first copy. So that means from enroll table in this case. So that's why we have 4 columns. Unit of study code we are not repeating because they are same. Title and column, and we have 1, 2, 3, 4, 5, 6 rows in there. Hopefully making sense how natural join works. Okay, so it will try to figure out the common fields, will match those and give you the whole row. Okay. It will automatically delete these duplicates like unit of study code. Again, in unit of study code, we don't need to store them because they are equal. Simply joining, checking whether they are equal. Okay, so that's why we can see them only once. Okay, hopefully that is making sense. So think about in a table, I have these 4 attributes. In another table, I have ACE. What will be the schema for our natural join is? Schema means what should be the attribute, how many attributes will we have, and what will be the attribute. Can anyone write how many attributes will be there in the resultant table if I join this R and S? Someone said 5. 5, 5, 5 so far. A, B, C, D, E. Someone gave us the answer. That's great. So yes, that is what we are going to get. Okay? Because A and A, they are common. C and C, those are common as well. So we'll write them only once. So A, B, C, D, E. That is what we're going to get. Excellent. What about this one? A, B, C, D, E. There are no common attributes, so we'll get everything back. Fully making sense now. What about this one? In here I have A, B. In here I also have A and B. Since everything is common, I will only get A and B. Right? So main thing is only the common attributes will be in the output. So we can figure it out. We can figure out from here how many attributes will be there. Number of rows depends on in how many rows they are equal. Right? Okay, things are going great so far. Set operation. 3 set operation we are familiar with: union, intersection, and difference. I'm guessing you all are familiar with those, so I'm not going to explain much. Union, this is the symbol that we are going to use. Intersection, this is the symbol. Okay, and difference is this minus sign. So union simply means everything from R and S you need to take. Intersection simply means what is it, the common part, this one, right? This dark blue part. And the minus simply means R minus S means that that is in R, but not in S. So only this part. So from here, only this R part, this common and whole S part should be gone. So that's what set difference means. One condition we always need to remember, and that is very important, they have to be compatible. When you are performing some set operation on 2 relations or any number of relation, at that time you need to make sure they are compatible. What does compatible means? Compatible means they have the same arity. That means number of attribute must be same number of fields or attributes. If in R I have 4 attributes, in S I must have to have 4 attributes, and corresponding fields must have the same domain. Okay, so in one table, let's say I have SID. In one table, I have SID only. In another table, I have, let's say, name. This is another table. Okay. The first condition is saying it needs to have same arity. These two tables, this is R, this is S, have the same arity, but they are of different type, could be. So let's say SID is integer, this one is string, let's add up. If I try to perform some set operation, let's say union, that one will not work. Okay, so we need to make sure that the domain is same as well. Okay, so if we are comparing SID, it could be SID, that's fine, but at least you need to make sure that the domain is same. Knowing that one, we want to answer this query. Return all students who are not postgraduate. I want you to run this query. Since you will not be able to write this operator, okay, what I want to do, instead of this one, in the chat box, you can simply write P. I will know that is projection. Instead of this one, you can simply write S. Okay, so you can write P, then something in here. Then if you want to write S in here, and then within bracket, you can write table name if needed. So this is what you can write in the chat box. So what should be the query for this one? Return all the students who are not postgraduate. So in here, we have all the students list. In here, I have the list who are postgraduate student. Now I need to figure out who are not postgraduate. Try to write, and then we'll check. You can see no answer for the time being. Okay, so let me give you some clue. So in the student table, we have all the students information. In the postgrad table, we have postgrad students. So who are not postgrad? So here, all the students here who are postgrad. So if I simply do a set difference between student and postgrad, that will be fine. Right? Someone gave us the answer. I'm not looking for the answer, but the relation algebra. Someone wrote that relation algebra for us. PSID student minus PSID postgrad. Excellent, good job. Okay, so think about, I simply need to perform a set operation, right? So I have student table minus this postgrad table that I have. That is the main thing that we have to do, this postgrad table. So if I simply do that, then I can get who are not postgrad student. But what we have just learned, when we are trying to perform a set operation, what we have to do, the arity and the type must be same. So in postgrad, the arity is 1 because I have only one attribute. In here, arity is 4 because I have 4 attributes. That one will not work. So from student, I first need to select the student ID. So how do I select? So we use project, right? So project SID. If I only do that, what is the thing that I'm going to get? Only this part, right? So this one will give me only SIDs, and in here I have the SIDs. So this is why we are writing something like this. Someone wrote projection on SID on postgrad, that's fine. But in here, since we have only one attribute, I don't need to do that. But if you do that, that's fine as well. Hopefully making sense. This is what we are going to write. From the student, first project on SID, then perform set operation with postgrad table. And that's how we can figure out who are not postgrad students. Okay. Last operator we have is rename. Rename, we can rename either relation, that means table, or the attributes if needed. Okay, and this is how we are going to write. So here expression means, expression E means any relational algebra expression that you can write, like we have written in the previous slide, right? So this could be an expression, the whole thing. Okay, so that is what E or expression means. So you can in here write the whole relational algebra and we can rename them. Okay, how we are going to rename them one by one if you want to do. So in here, let's say this one returns the number of attributes. So this X is saying what will be the table name. Okay, and this one is saying what will be the new name for these attributes that we have. Let me show you an example. Hopefully then it will make sense. So if I have a unit of study table and I'm writing rename UOS unit code title credit, what does that mean? So that means UOS is the new name of this table. U code will be the attribute of the first one, then title, and then this point will be converted to credit. Okay, so if I write something like this, this is what the change is. First, UOS, this is the X part, right? And in here, all the new attribute name that we have. So unit code, title, credit, that is what we're going to see in the output. Okay, why we do need to do renaming? So later when I run the SQL query, you will see that when I run the SQL query, it will automatically show the actual attribute name from the table, right? Probably we don't want to do that when we are building an application and showing it to the user, right? So we don't want to give any hint about our database to anyone. So that's why we can rename if needed. Okay, and this is the operator to do that. Okay, so these are all the operators we are going to learn on relational algebra. Okay, just a visualization who works on what. If you remember, projection works on columns, right? Selection works on rows. Cross product, if we cross two things, everything will be combined and we'll get a bigger table. So here, if I have n number of rows, here I have n number of rows. In here, we are going to get m into n number of rows. Join automatically checks the common fields. So here you can see this is yellow, that means they are equal, right? So when only we have the equal thing, that one will come in the output. We don't have anything equal, right? So that one will be discarded. Set union, when we are performing set operations, so union simply means take everything from these two. Set minus simply means in here we have that part, but in here we don't have that part. So this is the part that we are going to get. This part will be discarded because it belongs to the other relation. Finally, intersection simply means the common part. So this one is the common part. So that is what we are going to get. Okay. So hopefully these 7 are making sense. Projection, selection, cross, join, set union, set minus, and intersection. Someone is asking, with an outer join, we would get all the results, not just the similar ones, right? We'll talk about that, okay? Right now, probably will not make sense for outer join. We are in relational algebra part there, we don't have anything called outer join. Okay. For the time being, in SQL, we'll talk about inner join and outer join. There I will explain. Okay. Someone is asking why join get the color? Because we need to match whether they are same or not. Right. So this yellow means that these two are same. Okay, that's fine. Okay, so we learned about 7. Someone is saying why orange? So this one simply means that we have a value in here which does not match with any value on this table. Let's say this one is R, this one is S. We might have something in here which does not match with any of this. That's why a different color. Okay, so we learned about 7, but here we can see that 6 basic operators are there. Okay. 6 basic. Can we figure out which one is missing? The things that we have learned from that, which one is missing? We just learned 7, but this one is saying 6. Someone is saying join. Anything else is missing? Intersection, yes. Why those two are missing? Right? If you remember join, so join simply means that is a cross product with a condition. Right? Why intersection is missing? Because intersection, we can perform that one using union or set difference. Actually, we don't need union. We can only perform set difference and get that result of intersection. Okay, so let me write this way so that you understand. Let's say in set A, this is just mathematics. Okay, I have this 1, 2, and 3. In B, I have 3, 4, and 5. Now I want to perform A intersection B, but I don't have any intersection, but I know about set difference. Using set difference, can you give me the same output as intersection? Does anyone remember how to do that? What should be the equation, or what should I do on A and B so that I can get the same result? So A intersection B should be 3, right? Using only set difference, how can I get 3? We have learned this in mathematics, if anyone remembers. Someone said P minus P. So if I simply do P minus P, everything will be gone. A minus difference. Yep. So, yep, all of you are right. So first try to figure out A minus B. What is it that's going to give me? So in A but not in B, so that one will give me everything which are not common. Does that make sense? A minus B will give me everything that is not common between these two. In here, I have 3 and 3. So those one will not be in the output. So this one will definitely give me 1 and 2 only. So now I have 1 and 2. If I remove that one from A, then I'm going to get the intersection result. Right? So this one is going to get A 1 and 2. I remove that part from A, I am going to get 3. Right? So that is what is written in here. That's why, since we can perform intersection using this set difference, that's why this is not known as a basic operator. Okay. Join, same thing. We have already learned that when we have a join, we can write it this way, cross and then put a condition. So that's why join is also not known as the basic operator. Hopefully making sense. So these are the 6 operators that we can use, and intersection or join, those are there as well. Those are known as derived attributes, okay? Derived operators, sorry. So if you want to use intersection and join, you can use them, that's fine, okay? Just few things to remember. We learned everything that we want to learn about relational algebra. Just few things before we finish this part. When we are writing, there's a query for this. List the name of all students who are enrolled in relational DBMS. How should we write that query? We can write that query in many ways, okay? And different ways will have different cost. What does cost means? Cost simply means how long will it take to find the output. Depends on the table size, right? So if I ask you to find me the student name whose country is Australia, what do you have to do? You have to go through all of these rows. If it has 1 million rows, you have to go through 1 million rows and check whether this student's country is Australia or not, right? So if you have a bigger table, that means it will take more time. If you have a smaller table, that one will take less time. So which relational algebra will produce more and which relational algebra will produce less? That's what we have to learn. Okay. So this query I can run in multiple ways. This is one way. But to answer this query, let's figure out first how many tables do I need. To answer this query, how many tables do I need? What do you think? 3. Already I have shown you the answer, but yes, still. Why 3? I need relational DBMS. So relational DBMS is here. So I definitely need unit of study table. And I want to know the name of the student. So name of the student is in here. So this one should be enough. Why I need enrolled? Because you are saying 3. I need to know why do you think I need enrolled as well? Any reasoning? Someone wrote another to connect because they are related by enrolled. Because SID and code is in enrolled table. Yes. So now you can see that student and unit of study, I need to know that relation, whether this student is in this course or not. Where is that information? That information is the enrolled table, right? So we need to link these two tables. Whenever we are working on multiple tables, make sure there is a link. If there is a direct link, you can simply use those two tables. If there is no link or they are connected with other tables, you have to use that one as well. Okay, so that's why I have 3 tables in here. First, let's say I am doing a join on student and enrolled. So student and enrolled, that one will give me a bigger table. I am joining that one with the unit of study. So actually I am joining these 3 and then I am putting that condition. For the second case, first from unit of study table, I am projecting on the title where relational DBMS is there. So I'm first projecting, then I am performing this join. Which one? Let's say this one is 1, this one is 2. Which one have less cost? The table size is smaller. In which case? 1 or 2? 2, 2, 2, 2, 2. Everyone is saying that's great. Why? Right? So how many rows do we have in student table? 6. Enroll table? 6. Unit of study table? 6. Right? So we learned when we perform cross, this is actually a cross, right? So in maximum, we can have 6 into 6 into 6. But in the second case, how many can we have? Student table still 6. That's great. Enroll table still 6. That's great. But unit of study table, first I'm doing a projection, right? So from this 6, if I do a projection, only this one would come. Because title equal to this one, right? So this one will be 1. So now we can see 6 into 6 into 1, and this one is 6 into 6 into 6. Definitely this one will take more space, this one will take less space. So this one will be efficient, right? But both of them will give us the correct answer. Based on the efficiency, we'll choose the second one. In the exam, if you write either of them, that's fine. No issues, okay? As long as we get the correct output, that's fine, okay? At the last week, which is week 12, okay, there probably we'll talk about this sort of efficiency, okay? But as long as they produce the correct output in both the cases, they will produce the correct output, so both of them are fine for you to write, okay? So you don't have to worry about efficiency right now. Okay, so that's it about relational algebra, hopefully making sense. All the things that we have learned in the second part, we'll convert them into SQL, and then I'll write the SQL and show you the output as well, okay, so that we understand that actually works. Let's take a break, not longer than 3 minutes. After that, we'll start our SQL part, okay? So after 3 minutes, we will come back, take a break, drink some water, and then come in 3 minutes. I have a simple poll just to make sure that you know about that this week is the last week to form a group, okay? Just to check whether you have formed a group or not. And the first question is simply asking whether you are already familiar, okay? But go to a break, then come back, we'll talk about more. Okay, I'm back. Hopefully everyone is back too. Look at the poll. In the poll, share the result. Okay, for the first question, it looks like an even distribution. 54% already familiar, that's great. 46% no, that is also great. And have you formed a group? 98% people have already formed a group. That's excellent. So tomorrow is the last day to form a group. And during the weekend, I will randomly assign you to groups if you have not found a group yet. Okay, so if you want to join some other student of your choice, then you need to form that group by tomorrow. Okay. Next week, the assignment is coming, so we need to make sure all the groups are there. Okay. Now the important part is learning SQL. We'll start today. Next week, we will also continue. Okay, basic SQL queries. First we'll learn, then these join queries like we have learned for relational algebra, and the set operations like we have learned, right? SQL query, relational algebra is lower level, like I showed you there, right? Inside the system, converted to relational algebra. That is sometimes difficult, but SQL is high level, declarative language. Okay, SQL simply means structured query language. Previous name is a structured English query language, and that time this one is known as SQL. We'll sometimes hear this term as well, SQL. Okay, but now the new name is SQL. This English part is gone, structured query language. Okay, okay, nothing more to say on that. We are already familiar with this, that SQL query can be divided in three parts: DDL, DML, and BCL. We have learned about DDL, create, drop, alter a table. DML, this part we have covered also. Inserting into table, deleting some rows, in some modifications or update that we want to do. So this is the part we are going to learn this week and next week. Okay, how to write a query to ask a question, to retrieve some information from the database. Okay, SQL, it works for single table or multiple tables. Few keywords that we are going to use is select. First one, next is from, then next one is where. Looking at the keyword, it should understand that select simply means select the columns. Can you match? Which operator is this one? From relational algebra. From, here is the table name. We are simply going to write, and where. Here we'll write the condition to include the tuple. Tuple means rows, right? We'll also learn about group by and heavy, but not today. That's why they are grayed out. Next week we'll learn about group by and heavy. We will learn about order by today. So these four, select, from, where, order by, we are going to learn today. One important thing, when we are running SQL query, the result table can contain duplicate rows. If you remember, relational algebra automatically removes the duplicate rows, but SQL does not do that. So SQL will contain duplicate rows by default. If we want to delete that one, we have to do something extra. Okay, that is very important to remember. So remember that information. So if I want to write a query like this, list the name of all the student. On those three tables, where should I go? Student, that part will go in from, and then select what do I want to select. Okay, so this is the query looks like. Select name from student. It could not have been more simpler. Select the name from student table. That's what this will be saying. If I want to get all the attributes, so this one is the attribute list and this is the table name. If I want to get all the attributes, I don't have to write all of them one by one. I can simply use this operator. If you write all of them like name, SID, gender, country, that's fine. But if we want to get all the attributes, you can use this wildcard, okay, asterisk. For the simplicity, I will tell that one as a star. So I'll simply say select star from student. Okay, that means select all the attributes from student table. If I want to put some conditions, select all the students who are from Australia, select the name from student table where country is equal to Australia. Okay, very simple to understand, and just writing this line will get the output. I will show you. So this is the general format. In select, we will write the attributes that we want to see in the output. From here, we will write the table names. If you have more than one, we will simply separate them by comma. So we'll write, let's say, student, comma, enroll table. That's how. And in this part, all the conditions will go. Whatever conditions you have, you can write that one inside where. Okay. So select from where query is equivalent to relational algebra expression of something like this. Can you figure out which part is what? Select means the projection in relational algebra, right? So projection also works on the column. So select is also working on column. From, that simply means the Cartesian product. So if I write multiple table names there, we'll put the Cartesian product inside this bracket. That part will go in from. In where we will have the selection operation, that means the condition. So let's say I want to convert this query, select name from student where country equal to Australia, to a relational algebra expression. How should that look like? This one should be the equivalent one. Have a look. Does that make sense? From student table, put that condition where country equal to Australia, and then do this projection name. Right? So these two are actually equivalent. This is what we are going to run, and we are going to see the output from there. Before I run, I will run all of those. Okay, but before I run, just few things we need to remember. SQL commands are not case sensitive. That's good news for us. So if you write select in capital, small, mix, everything, that's fine. It is not case sensitive, the commands. You have to use single quote when you are working on string, right? So if you are comparing, let's say, Australia, you cannot use double quotation. That one will throw an error. You only have to use single quotation. But string constants are case sensitive. Remember that commands are not case sensitive, but when you are working on value, at that time they are case sensitive. So if in your database the country is written as AUS all capital, you are writing in this way, it will not find anything. Okay, value is case sensitive, commands are not case sensitive in SQL. Okay, so let's run few queries so that you can understand. Yep, hopefully this query is now making sense. Select start from students, this is the exact table that we have seen, and we can see this one in here. So if I want to write something else, select name from student, then you put a condition where, let's say, country equal to Australia. We run, we are only going to get Jan and Grant, right? If I write this one in AUS, I will not get anything because I don't have any country name which looks like this, because this is a value. In the table, this is written as this. If I write a star, then we can see everything. Here we can see the country is written as AUS. So that is what we have to write. If we have multiple conditions, we can put that one using AND. Okay. Let's say country equal to Australia and gender equal to L. Put that one, this is the same result that's coming up, but it's not complaining. Okay, so in this case, and we'll simply write and. If it is or, we'll simply write or, those sort of things. Okay, hopefully got few idea. Like I said, it will not remove the duplicate automatically. If you want to remove the duplicate, then you have to do something extra. Okay, so like if I write select country from student, it will give me the country names, the country which are in your table, right? In here, you can see Australia and Australia twice. Probably I don't need that because I'm simply trying to figure out from which country the students are coming from, and I don't need Australia twice. Only once will be fine. So if we want to do that, we have to remove that one by ourselves using a keyword called distinct. And we have to write that after select. So we have to write select distinct country from student. If I do that, only then we will be able to see that Australia will come on once. If any repetition there, that one will come only once. Look, let's say I'm selecting select country from student, no condition is there. If I compile and run, you can see Australia is coming up twice because SQL does not remove the duplicates automatically. We have to do that ourselves. You can see that I am writing this command in capital letter just to show you that those are commands, okay? But any case is fine. They are not case sensitive, okay? You can write everything in one line. Those sort of things are perfectly fine. Another thing I'll just show you, if you need to go back to your previous query, in the query history, you will find all the queries that you have written, okay? Last 20 or 25 sort of queries are already stored there. You can simply copy paste from there if you need, okay? So let's say I am simply taking this one, copy to query editor, and you can see that that query comes up here. Right, run that one will work. Okay, so in query history, you can find the previous queries if you need to go back to any query. Okay. Okay, so that was another thing about distinct, hopefully making sense. Simple thing, if you want to remove the duplicate, you have to use this keyword. Select. In the select clause, we can perform any arithmetic operation that we want. Okay, arithmetic operations, plus, minus, multiplication, division, any sort of mathematical operation you can perform if needed. Like let's say I want to increase the point for each unit by 2. Okay, so points multiplied by 2, that one is perfectly fine. Let's have a look. What do we have in? See, let's start from, I think I have unit of study table. Yep, unit of study table is there. I want to increase the points. Select, let's say title, and points into 2 from unit of study table. Okay. Next thing to remember, these changes that I am making, they are only for your output. The actual table is as it is. Okay, these are not affecting your actual data that you have in the database. If you want to change anything in your database, then you have to use update, right? Delete, those sort of things that we learned last week. So this one is only showing in the output, but in the original table, everything is still 6, 6, 6, 12, 4, and 18. Okay. Don't make the mistake that we're doing. By doing that, we are changing the value in the database. That is what we are not doing. Okay. Very simple. Where clause, there will put all the conditions. The result must have to satisfy. Conditions like we have already seen equal to, where country equal to Australia. Okay. Greater than, less than, not equal to operator, both one will work. So this is not equal to, this is also not equal to, both will work on PostgreSQL, I think. Yeah, we'll check. So any sort of condition that you have, logical condition you can put there. If you have more than one condition, like I showed you, you can write and, or not. That's fine as well. So if I have a query, find all the unit of study for units taken by student 1001. So this is the student ID in this. So this is the semester information, right? What should the query look like? Can you write? I just want to make sure whether you are very quiet. I just want to make sure you are there. Can you write the query for this one? In the chat box, select from where, what do we write? Do you need to see the tables? Probably that one will help. If you don't remember the attributes. Yep. Yes, from this table, write this query. Find all the interview study code for units taken by student 1001 in 2021 is 2. Someone wrote select inter-study code from enrolled where SID equal to 1001 and semester equal to this. Excellent. First thing we need to figure out in which table or how many tables do we need in this case, right? Yep, next answer looks like right as well. Yes, excellent job. Okay, so how many tables do we need? We need only one table enrolled because I have SID. Here is the SID. I have semester information, and we are looking for interview study code. So all those informations are there, right? Yep. So this is what the query should look like. Select interview study code from enrolled where SID equal 1001 and semester equal to this, right? Let's write that one. So this is what we have seen there. Select, let me copy from the chat box. I have that thing there. This is what I have copied from the chat box from one of the answers. Just to show you, I'm putting them in different lines. I need to change this. So select interview study code from enrolled where this will not do that. If I compile, no output should be there, right? So in here, I don't have that semester. We can try with another one. Let's say 2020 is 2. You can see that there is no output, but in here there should be 1. Let's check. So 20201001, that's the student ID. So student ID 1001. So this the first one should come. This one should not come because this one is 2020 S1. We are only looking for S2 students. Right, so that's why we are getting COMP9138 in this case. Yeah, so everyone who wrote the answer, thank you. Everything was correct. Well done. Next. Learning this one, when I learned this one as a student, I was amazed. Okay, like how simple SQL is and how simply writing keyword called like, we can perform a lot of things. So like is used for searching. Okay, so all the search that you do in Google or anywhere else, in the background they have nothing but the use of like. So they simply have like. So let's say I want to figure out all the titles where there is comp written in the title. Okay, so if I want to figure out all of those, how should I figure out? So select the title from interview study where unit code like comp, then there is a sign, right? What does this sign means? So this one means that first 4 characters will be comp and then anything there is, that's fine. It will give us the answer. Okay, so first 4 should be comp, then there is anything. So this one means anything after that. In interview study code, we'll look for this data. And that is what search is. So in every document, like the keyword that you search on Google. Okay, so you are looking for COMP9120 database. That is the thing will be written in here, and this is the query that we are going to write. Okay. Just to make sure you understand this nicely, let's say, let me show you one table, then we will work. So let's say this is the student table. Okay, I want to know how many students' name starts with S. How many students' name starts with S? Select name from student where name like, then starting with S, right? Let's say capital S. how many outputs should be there? If I run this query, only one. Okay, yep. Only one, Simon. Looking into the names, why does not JC comes in there? Because this one is saying first you need to have a capital S, then anything that you want can have, right? JC does not have S in the first position, that's why that is not coming up in there. Okay, so if we understand that, and I'm writing something like this, %n, looking into this table, how many output will be there? Have a closer look on student tables, student name. Hopefully that is big enough for you to see. If I'm writing something like this, how many output will be there? I can see 2, 2, 2, 2, 2. Okay. Someone said 3. Most of you said 2. Only one person said 3. Someone wrote the answer for us, Simon and Jan. Yes. So now what this one is saying, anything but ending with N, right? Jan, anything ending with N, Jan, Simon, anything ending with N, Grant, it is not ending with N. After N we have T, right? In here we have N, but after N we have something else. So those things will not come in the output, right? So only things that are finishing with N, those two will come up. I made a mistake where name like syntax error. Let me check. Yep, everything is fine. Okay, so Jan and Simon should be there. Okay, now if we understand that, let me check for something else. What about this one? How many output will be there? 4, 3, 4, 4, 4. Most of you are saying 4, only one people say 3, another one is saying 3, 3, 3, 4. Yep, there is some confusion. So what does this one is saying? Anything on the front, then A, then anything. Okay, here anything means you can have nothing as well. So if you have A at the end, that's correct, right? If you have A at the start, that is correct as well. So anything means that there could be nothing as well. So if I run this one, then 4 will come, because why A, right? So I have in small a, and A in the end. This means anything, that means nothing could be there as well. Okay, hopefully that one was confusing, but hopefully now this one is making sense now. Just last one, okay? How many output will be there? This is the last one. %, how many output will be there? Someone said 0, other people are saying 1. First, need to have a look that this is capital. So we need to look for capital H. Okay, so this is small h will not be the output, right? But this ha starting with H, that would be in the output, right? Yep, ha would be in the output, so 1. So this one means anything, that also means that nothing could be there, right? So that means we can start with H. So whenever we have capital H, that is the thing that you are going to get. So just think about just writing this part, you can find anything, right? So in any document, if you just put that keyword in here with person at the front and at the end, right? Then you can get all the words that contains that information there. And that's what is done in the search engines that we use. So anything you write in the Google search box, that thing is written here, and then 2% size. Hopefully making sense. So yep, so percent means it matches for any substring. We can have underscore. Underscore matches with any single character. So if I write, let's say H and then an underscore, it simply means that after H there will be only one character. Okay. If I write like this, so it simply means after H it will be 2. Someone is saying, what about if we only want the middle, not the first and second? Then you have to write that query yourself. Okay. So you have to get all of those, then you have to do some set operation to remove those things. Someone is saying, can one be nothing? In this case, no. Okay, so in this case, there will be a character. Okay, so it matches any single character. So there will be a character there. Okay. We can concatenate 2 strings using this operator. That way we can combine 2 strings together. We can convert from uppercase to lowercase or lower to upper. Okay, we can find string length, we can find the substring, those sort of things we can perform in this string. Okay. Okay, rename operation. Simple keyword as is the one that we are going to use to rename. We can rename 2 things, either table attribute or the table. Okay. So let's say I have this query, find the unit of study code, credit point for this unit. Rename this column to course code. So unit of study code, we want to change that one to course code. This one should make sense. Forget about this S part. First have a look, select from and where, whether that makes sense. If yes, then using as, we can simply rename one attribute. So course code will be there for unit of study code if we have. In here, you can see as is not used as well. So that's fine. PostgreSQL supports that. So as is totally optional. If you don't write as, that's fine. But if you simply give any space, that one will rename to new name. Okay. Let me show you. This one sometimes makes some confusion. So select name from student table. So that is what I'm going to do first. So first have a look that this one is showing name, right? So that simply means that you can see the attribute. Anyone who is writing this query can see the attribute name, which is name. If you want to change that one, 2 options you have. You can either use as, let's say student underscore name. Will not be able to put in space. Okay, so that's why I'm using underscore. So now you can see that this one has changed to student name. Someone is asking, if I use as, I cannot call the original name after that. In this query, no. But again, in the database, everything is written as it is, right? So you have the things in the database saved as, but in this table, if I remove as, that one will also work. Okay. So in here, select name, student name from student, right? You can see that without using as, I can change the name. Let's say I want to change the table name as well. Student, I don't want to write student. I only want to write s. I can do that. Let's say I want to write s.name. This syntax I will explain, but this one simply says table name dot name. So from this table, show me this attribute. Sometimes we will need that when we are working on multiple tables. Later we'll see. So this is how we can use, instead of writing student.name, I can simply rename to a shorter name, let's say s, and I can write s.name, and that one will be perfectly fine as well. S, I'm not sure why sometimes it doesn't work, but everything is fine. Yep. Right. So we can get everything where this table name has been changed, and in this case that name has changed. So if I have something else, I can keep writing. That's fine. Country will come up as country as it is. If you want to change that one, you have to give a different name. Okay. So let's see student country. That's how we can change these attributes one by one if we want. So that is what rename is. Using as, if you simply give a space, that one is fine as well. Order by. Order by simply means if we want to see the result in a particular order. Okay, so this is the keyword that we are going to use is order by this. So I want to see all the students' name in alphabetic order. So I can simply write order by name. Now, when we are talking about order by, there are two sorting order, right? Either ascending or descending. If I don't mention anything, that means that is ascending. Okay, so if I simply write order by name, then I'll see the name from A to Z, starting with A, finishing with Z. If I want them in descending order, I have to write descending, which is DESC, that is the keyword. I can order them by multiple attributes as well. So if I write order by country descending, but name ascending, what does that mean? So since this is the first one, he will first order everything with country. If two rows have the same country, at that time, those two rows will be sorted by name. Again, first we'll try to sort by country. If two countries have the same name, at that time, the student's name, let's say, will be ordered in ascending order. Okay, let me show you. Hopefully then things will make sense. We remove everything. Select name from student, order by name. This is what we can see. Since I'm ordering starting from F, G, H, I, J, then S, because this is ascending. If I want to change that one to descending, I have to write that one specifically. Now you can see that that has changed. Let's have a look when we have multiple. So what does the output should look like? Country first. Nothing is mentioned, that means ascending. So that's why we are starting with A, finishing with R. These two have the same name, Australia and Australia. That's why we're saying Ian first and Grant then, because this is descending order. If I remove descending, then Grant should come up and Ian should be in the second position, because this one will sort that one in ascending order, right? I'm not sure why this one sometimes does not work. Yep, but it's working now. Now I can see Grant and Ian because name is also ascending for these two. Hopefully making sense. First order with the first attribute. If the value is same, then use the second one to sort. If we don't write anything, that is ascending. If we want to do descending, we have to write that one specifically. Okay, so that is the basic part. Join. Join simply means we are working on multiple tables now. Okay. Instead of one, we'll work on multiple tables. When we are working on multiple tables, we simply separate them using comma. Okay. So let's say the question is asking, find the student ID, name, and gender of all the students enrolled in this one. Okay, so a few conditions are there that enrolled in this unit. I want to see ID, name, and gender only of all the students who are enrolled. So if I want to figure out the ID, name, and gender, ID, name, and gender, I need to go to student table, right? But this information, info 007, whether the student is enrolled in that one, that information is in the enroll table. So I need to access these two tables, student and enrolled, right? So student table and enroll table, those are the two tables that I need to use. And these are all the conditions. When I need to be static code, you go to this one. What is this condition that I have in here? Remember this simple thing. Okay, don't complicate the things. Simple thing. When we are using multiple tables, there must be a connection. And we will write that condition here. What is the connection? So in student and enroll table, the connection is using SID, right? So the SID of this student table must be equal to the SID of enroll table. That is what we are writing. So we are simply saying what is the link between these two tables. So student ID SID is equal to enroll.SID. We'll talk about this one more, but for the time being, just remember, whenever you are working on multiple tables, more than one, you need to mention the link. Okay. If you don't do that, then you will get wrong output, incorrect output. Let's have a look. Let's say I want to know name and country from student and enroll table. Whatever could be there if needed. Where student, now we can see that I have to write, first let me write this one. And what is the attribute name? I forgot. Unit of study code, unit of study underscore code is equal to something. Info 6007. If I run this one will come up as an error. Okay. Remember this word ambiguous. Ambiguous simply means he does not know where this column is referring to. That simply means this column name exists in more than one table. So he does not know which table, from which table he needs to get that information. So we can see in student and enroll, in both the table I have SID and SID. So when I'm writing SID equal to SID, he does not know, does this SID correspond to student table or enroll table? That's why he is saying this is ambiguous. What we have to do, we have to mention the table name in that case. We have to write student tables SID should be equal to enroll tables SID. Since there is an equal sign, it does not matter if you write first enroll then student, that one will be fine as well. Now we can see, yes, it comes up with a result that Ian is enrolled in info 6007. Let's have a look. Ian 1001 1001 info 007. Right? So he is the student who is enrolled in this course. Hopefully making sense. This is the thing that I mentioned earlier. Now you can see that I have to write the whole table name. If I don't want to do that, this is what we normally do. We give this table a shorter name, right? So s.sid equal to e.sid. This is what we normally write. If I want to see the student ID and I write something like this, this one will again come up with an error and the same error will be there. Okay, because this one is saying SID, he does not know from which table. You have to mention the table in that case. Someone is saying, what will happen if I don't put that condition? Let's see, and then we'll try to understand. Can you see? It gives us all the things that we have because he's not comparing whether this student is enrolled into that unit. Okay, so I have removed that one, so I am getting all the students' information there. So that is totally wrong. So he's not comparing a student ID with the student ID to check whether that student is enrolled in a particular course. Right? So he's giving me every student's information, all the condition information are there. Does that make sense? No. Let me show you just a little bit of explanation why everything will come up. So if I simply do this, okay, yeah, that's fine. Probably no, this is not what I want to explain. Probably I want to show you everything. So if I do something like this, student is enrolled E, I don't need these ones as well. Yep, same thing. Just have a look at the output. So can you see SID and SID here? All of the SIDs are there, right? So in here, have a look. Can I make it a little bit bigger? Yep. Have a look. Here I have 1001, 1001. That's fine. 1002, 1001. It's also there because he's not comparing those two and only checking getting the matched value. So he's getting everything, right? So that's why we are getting all of those results, all the students. So between these two tables, there is a connection using the SID. That is what we have to mention, and only then he will get the correct table. From there, he will do this projection or any other condition that you might have. Okay. So every time you are working on multiple tables, make sure you put that condition. This is what I tried to explain. Okay, so this one simply performs the equality check for the common attributes of two tables. If anyone have forgotten about relational algebra that we have learned, this is just to remind you. If I want to convert this SQL query into relational algebra, this is what it looks like. Have a look. Does that make sense? Hopefully you have not forgotten. So I'm doing a lot of things. First, I'm renaming student table to S, enroll table to E. That is what is done here. Row S, row E, we are changing the name. Then we are checking the condition S.SID equal to E.SID. That is what the condition part is. And I'm selecting these three in projection. Right. Hopefully making sense. Why we have to rename? Another use of rename is sometimes we might need this information that we have to use the same table twice. Okay, you can see the same table, lecturer and lecturer. I'm trying to figure out a lecturer and his immediate supervisor, his manager. Who is this manager? So how many tables do I need? In the same table, I have that information. Let's say I have lecturer's name and his manager's name. Okay, so the same table, since I have both of those information, I might need to use that table twice. If I need to do that, then I can do that using rename. If I simply write lecturer L, lecturer M, that simply means I have one copy, which is L of the lecturer whole table, and I also have M, which is the whole lecturer table. Then I can compare. Okay. If that makes sense, I have created one employee table so that I can show you. Okay. So here you can see employee's ID and his manager's ID. Okay. Employee ID and manager ID. But I want you to print employee name and his manager name. Not ID, but I want to print out this one. What query do I have to write? I want to write employee name and his manager name. Now we can see that that information is in the same table because this manager is also an employee, right? So 104, I need to get that name from this table as well. So I have to use this table twice, right? Because of time, I'm not writing this one at the time being, okay? But this is the answer that you have. Try that one and hopefully you'll understand. Join. Someone was asking about outer join before. So this is where this comes. So inner join and outer join. What does that mean? So the joins that we have seen so far, those are inner join, okay? Because they are only working on matching rows. If you remember, they match, right? Whether this one is equal to that one. If we work on non-matching rows as well, we want to get all the rows which does not match as well. Okay, that one will be known as outer join. In inner join, we have learned about theta join, equi-join, natural join. Those are the things we have seen. Outer join, we have few things like left outer join. It simply means take everything from the left table. If there is some unmatched item, then input null. Very simple thing. Okay, I'll show you and you will understand. Right outer join simply means take everything from the right table. Okay, if something does not match, put null. Full outer join means take everything from left and right, try to join. If there is nothing for some attribute, put null there. Okay, let's try. These are simple things, but will help you later. So let's say I'm writing select star from student. I have not written from and unit of study. First, this is the query I'm going to write. This is the whole thing that I'm seeing. What we have learned, whenever I'm working on multiple tables, I need to make that connection. So even if there is no condition, I need to write student.sid to make that connection. Right? Let's give it a small name, u.sid. Someone said something before, when I have something selected, that does not work. Probably that is the reason. U does not work. U.sid does not exist. Sorry, this should be enrolled table. It's not the problem. Problem is here. Okay. Yep. So now you can see 6 results coming up, right? With all of these matches that we have. Here you can see 1001, 1001, 1002, 1002. So all the matching things are there. I can do that automatically without doing this linking manually. Okay, first thing is that one. If I simply use natural join, that's what we learned, right? Natural join does that equi-join for us. So if I write and run, you can see the exact same thing. Okay, so if we have any common attributes, those are automatically checked when we are writing natural join. So that is the difference. Either you can write in where clause, or you can simply write natural join in here if you want. There are many ways to write that condition that I was writing in the where. This is one. Another one is, let's say you are thinking about theta join, and there you want to put some conditions. Okay. Let's say I'll write natural join this one on what should be the condition. If you want, you can write that one in here. Okay. So the condition was, let me put in a different line. Condition was, let me give it a small name, that s.sid is equal to e.sid. I'm guessing the syntax is correct. I've forgotten the syntax, not natural, only join probably should be there. Yep. So when you are writing natural join, that thing will happen automatically. If I don't write natural but put that condition, I can write that one in on. Okay. Another way is writing using. I can simply write using SID. That simply means you will try to compare SID of these two tables. Okay, you can see the same output there. These are the things written in here. Many ways to write: join, on, join, using, simply list of attributes, or you can write natural join to combine all of those tables. Okay. Last thing for today I'll show you is these outer joins. Okay. So let's say first I'm writing this one and left outer join. That is the keyword that I have to use. Just looking at the output, you'll understand. Syntax error, left outer join. Do I need natural? Natural, probably I need, yep. So natural left outer join, sorry about that. That is the keyword that we have to use. So now you can see instead of 6, I have 8 because all of the things from student table are here and there are some null values. Because for the student, I don't have any of static code. So that's why he put null in there. Okay. If you remember when we simply did natural join, only 6 rows came up. These 2 are not there. When I'm doing left outer join, everything from the student table are here. If no value found, they are null. I can do the same thing with right outer join. Everything from enroll table should come and all the student, they are in the enroll table, they are in the student table, must be there, right? Because this is the foreign key, so that's why we have only 6. If we have some unmatched data, that will be represented with none as well. We can do the same thing with full. In this case, I'm guessing 8. Yep. So in this case, we'll get everything, and that is what we have. Okay. So try to practice all of these, and hopefully then these things will make sense. Because of time, I will not complete this next part. That's fine. Next week we'll also cover SQL. Okay. So we'll again talk about set operation next week. So that's it for today. We'll cover set operation next week. Okay. In today's tutorial, you will practice this relational algebra. Okay. And also I have given you an announcement that you have access to Grok now. If someone has not seen that announcement, go to our 8th page. There you will see the link, and there you will see practice material in Grok. Okay. Okay. Someone is saying access to what? Access to this Grok, this course that we have. Okay. Okay, so that's it for today. Thank you, everyone. If you have a tutorial session, go to the tutorial session. If you have any question, feel free to ask. Next week, we'll also learn SQL. Okay. Someone is saying, is there any intermediate Grok course after that one? No. This basic course is there only. Okay. But there are a lot of things I think you can practice and learn from here. Okay. Is there any exam on the Grok? No. In this unit, we don't have any exam on Grok. That is simply for practice. And do we must finish the Grok? I will suggest yes, but that is not marked. Okay. Look at that announcement in 8. Probably that will answer all of your questions. No question. Okay. Thank you, everyone. See you next week.